Okay, today we are on 18B and we are completing the graphs 1 through 9. So I'm going to lead you through a couple of them, and you could still look at a graphing calculator if you need some help. And then you'll have to do a few of them on your own to post. So the first example, we're going to go through our steps, the y-intercept, the x-intercept, the asymptotes. There's some notation down here that I'll explain what that means. So first, to find the y-intercept, we plug in 0 for x, remember. So if I plug in 0, I get 6/3, which is 2. So I'm going to go to 0, 2 and plot a point for the y-intercept. For the x-intercept, so I'm just going to write here, plug in 0 for x. The y-intercept is to set the numerator equal to 0. 6 can never be 0, so there's no x in the numerator there, so there is none for the x-intercept. Domain and range, I like to skip until the end once I look at the graph. And then for the asymptote, so the vertical asymptote, what would make this denominator 0 would be -3. So my vertical asymptote is x equals -3, and I'm going to put my asymptote line like that. And then I have to compare the powers of the numerator and the denominator. The denominator has a bigger power, and whenever the denominator has a bigger power, it will have a horizontal asymptote at y equals 0. The denominator gets bigger, and so a number divided by a very big number approaches 0. So this is what I've got on my graph right now. So in this region, I know that this elbow goes through the y-intercept, it must approach this asymptote, and it must approach this asymptote. I'm not sure in which region my other elbow is. It's probably down here. They're usually opposite each other. So I need to plug in an x value. If this is -3, an easy one to plug in would be -4 and see where that elbow is. So if I plug in -4 up here, I get 6 divided by -1, which is -6. So I know that -4, -6 lies on this graph. And so this elbow must go kind of in this direction. It hugs the two asymptotes and it goes through -4, -6. So now I can take a look at the domain and range. What x value was bad? X cannot be that asymptote, right? X cannot be -3. What y value was bad? It was y equals 0, so y cannot be 0. And I wanted to explain this notation. This just says as x goes to infinity. What side of the graph goes to infinity? The right side of the graph, right? What is this part of the graph doing? Isn't it approaching 0? The function approaches 0 is what this says. What about as x approaches -infinity? What is this side of the graph doing? Isn't this arrow also getting closer to 0? So that side of the graph gets closer to 0. Then this says as x approaches -3 from the right side. That little plus sign means the right side. -3 is our asymptote. If it's approaching that asymptote from the right side, I'm talking about this part of the graph right up here. Isn't that going towards positive infinity? So the function is going towards positive infinity. And then this says as x approaches -3, but from the negative side, the left side. What is this side of the graph doing? It's going towards -infinity. So that's just an introduction to some limit notation that you will see in our last unit of the year. It's not going to show up on a lot of your test or quiz, but just a good introduction to limit notation. So now let's do number 2 together. It's very similar to number 1, so maybe you want to pause the video and try it on your own first. To find the y-intercept, I'm going to plug in 0 for x. I don't know what 19/76 reduces to. Oh, it actually reduces to -1/4. So my y-intercept is right there at -1/4. My x-intercept, again, there is none. I have 19 in the numerator. That can never equal 0. For my vertical asymptote, what will make this denominator 0? Well, if I add 76 to the other side, and divide by 38, I get 2. Because 76 divided by 38 is 2. So my vertical asymptote is at x equals 2. Again, the denominator is bigger than the numerator for x powers, so I have a horizontal asymptote at y equals 0. And so this elbow of the graph is going in this direction. So I would assume this elbow goes over here. What would be a good value to plug in? How about positive 3? So if I take 19 and divide by 38 times 3 minus 76, what will I get? 19 divided by another parenthesis, 38 times 3 minus 76. Oh, I guess I only needed one parenthesis. Okay, denominator is in parentheses. I get 1/2. So at, what did I plug in? At 3, I'm at 1/2. So that tells me that this elbow is over here, above this asymptote. And now I can do my domain and range. So my domain is that x cannot be 2. My range is that y cannot be 0, which comes right out of my asymptotes. And let's do that analysis. As x goes towards the right side, what's my function doing? It's getting closer to 0. As x goes to the left side, the function also gets closer to 0. What about as x approaches 2 from the right? As x approaches 2 from the right, it's going towards positive infinity. What about as x approaches 2 from the left? It's going towards negative infinity. So those were very similar with their asymptotes. So let's take a look. I want to do 2 more with you, and then I'm going to have you finish some on your own. So let's see. I'm actually going to do 5. So 5 has a bigger power in the numerator, x squared minus 9 over x minus 1. All right, my y-intercept. When I plug in 0 for x, I will get negative 9 divided by negative 1, which is positive 9. Plot that. X-intercept. This numerator is factorable. X plus 3, x minus 3, difference of squares. So I have 2 x-intercepts. One at 3, 0, and one at negative 3, 0. For my asymptotes, the denominator, the vertical asymptote, is going to be at positive 1 because 1 minus 1 is 0. And we have to do division, right? The numerator is bigger, so I need to divide. So see if I can find room. X minus 1 needs to get divided into that that binomial. X squared minus 9. X squared is going to go here. X times x is x squared, so I'd have negative 1x. How many x's do I have in this dividend? I have 0 x's. I have x squared, but I have 0 x's. So if I already have negative 1x, I need positive 1x. So that adds up to 0. So the last part of my division is going to be x plus 1. If I wanted to continue, then this would be negative 1, remainder of negative 8. But I don't really care about the remainder. Y equals x plus 1 is my slant asymptote. So that's y equals mx plus b. So I'm going to go to 1. I'm going to go up 1 over 1 for a little while. There's my slant asymptote. And I had another asymptote at x equals 1 that I didn't dot in. So here's this. This is a slant asymptote. A slant asymptote kind of gives you like a bended, curved graph like that. A little bit different looking. My domain is that x cannot be 1 again. But my range is actually all real numbers. So there's no horizontal asymptote. This goes forever up and down. So my range is all real numbers. So I'm going to choose to do number 6 now because 6 is the last type of asymptote that we haven't done. What is my y-intercept? Plug in 0 for these and you'll get negative 7/5. 0, negative 7/5. It's just a little bit more than negative 1. So I'm going to put it between negative 1 and negative 2. my x-intercept, what will make the numerator equal 0? X would have to be 7. I'd add 7 to the other side and divide by 6. 7, 6, comma, 0. That's just a little bit more than 1 for my x-intercept. My vertical asymptote, what will make this denominator equal 0? -5 divided by 2. So x equals -2.5 or -5 halves. Okay, -2.5. And then remember, when the powers are equal, linear function, you're going to strip those coefficients of x. This is going to grow at the same rate. So like 6 billion divided by 2 billion. Those are the significant terms. 6 halves is the same as 3. So this is going to have a horizontal asymptote at 3. Here's that bottom part. And then I'm going to plug a value in over here, like maybe -1, 2, 3, maybe -4, and see what I get in my original function. I'm just going to use my calculator. So if I plug in -4, I would have in the numerator -24 minus 7, and in the denominator, I'm plugging in -4, so -8 plus 5. 10 1/3. So over here, I'm way up at 10 1/3. Can't quite fit that, but opposite elbows once again. Okay, so we've done those 4 graphs together. I'm going to have you do 4 graphs on your own, 3 and 4. These are a little bit trickier to graph because of asymptotes. So I recommend, I was supposed to do domain and range, but let's see. These both have horizontal asymptotes, right? X cannot be -2.5. Y cannot be 3. All right, so make sure when you graph these, they're going to have a couple different regions. You look at a graphing calculator for 3 and 4, and then I'm going to have you do 7 and 8. And then we're going to do number 9 as a warm-up next time together when it's a cubic divided by this quadratic for the slant asymptote. So you need to complete 3, 4, 7, and 8 and post those in Google Classroom.